Today we're going to find the greatest common factor of two numbers. Our goal is to find the greatest common factor of two or more numbers. Let's look at our vocabulary. Our two key vocabulary words are common factor and greatest common factor. The definitions. Make sure you're copying these down carefully. A common factor is a whole number that is a factor of two or more non-zero whole numbers. Again, they are non-zero whole numbers. The greatest common factor is basically just the largest of the common factors. It's abbreviated GCF, or the greatest common divisor is another word for greatest common factor. And I'll show you an example of why another term for it is greatest common divisor. So let's look at an example of greatest common factor. What is the greatest common factor of 12 and 16? So looking at these, we first just need to list all the factors. This is one way of doing it. Of 12. So the factors of 12, we of course, those are the numbers that we can multiply together to get to 12. So 1 times 12 is 12. So those are both factors of 12. Those are, of course, the obvious. And I have all this space in between because I like to write it in numerical order the best I can. So then I just go down the line, and we looked at divisibility rules, and those divisibility rules can really help you here when finding greatest common factor or greatest common divisor. So we have 2 times 6 is 12. And I'll separate that with a comma. And then, of course, we can go down the list. 3. 3 times 4 is 12. And then once you get to two numbers that are 1 unit apart, that's kind of a hint that you have all your numbers. But you can keep going down the list to see, okay, is 4 a factor? Yes. 4 times 3 is the same as 3 times 4, so we don't need to list it again. 5 does not work because it doesn't end in a 0 or a 5. And again, these are all of the factors we have. 1, 2, 3, 4, 6, and 12. Now, looking at 16, let me do that in a different color. Of course, the obvious, 1 times 16. So then, of course, 16 is even, so we have 2, and we know that 2 times 8 is 16, so 2 and 8 are both factors. Then we look at 6 and see if 3 is a factor. Well, 1 plus 6 is 7, which is not divisible by 3, so 3 is not a factor. However, 4 is a factor. 4 times 4, I don't need to write it again, and then I can, of course, go down the list, but again, I have 4 times 4. That's a pretty good hint that those are all the factors. So I can probably clean this up a little. There. Now we have a cleaner looking problem. And we could go down the list if we wanted to. So now we need to identify the common factors. Well, we have 2. We have 1, of course. We have 4. And then we can look, and those are the only common factors. Sometimes you will get a greatest common factor of 1, by the way, but very rarely, only if one of them's prime, usually. So looking at these, we have 1, 2, and 4 are the common factors. So common factors, 1, 2, and 4. And then we just need to look at the greatest common factor, or the largest of those, and 4 is the largest. So the greatest common factor of 12 and 16 is 4. So hopefully this is looking familiar. You're remembering it from previous grades. So now we're going to take it a little bit further and make it more challenging. One thing I want to point out is that it is important that you know how to do this. Finding the greatest common factor is very important to help you reduce fractions, find common denominators, and to factor polynomials later on when you get into higher level mathematics. So this is an important concept to understand. Let's look at another example. What is the greatest common divisor of 12, 42, and 70. Now remember, greatest common factor and greatest common divisor are synonyms. So first we're going to write the divisors of 28, 42, and 70. In other words, we're going to write the factors. Now we're going to do this by listing the factors. There's another way of doing this, and we're going to get into that on another tutorial. But for now, we're going to list the factors of 28. So the factors of 28, we of course have 1 times 28. Other factors, now we know 28 is even, so 2 is a factor, and 2 times 14 is 28, so 14 is a factor. We know that 8 plus 2 is 10, so 3 is not a factor. 4 is a factor because 4 times 7 is 28. 5 is not a factor, and of course if 3 is not a factor, 6 is not a factor. And then that brings us to 7, and now we've gone in order. So these are all my factors of 28. Let's look at factors of 42. Well, we have 1 times 42. 42 is even, so 2 is a factor, and we know that 2 times 21 is 42, so 21 is a factor. 4 plus 2 is 6, so 3 is a factor, and 3 times 14 is 42. 4 is not a factor of 42. However, if 2 and 5, of course, is not, because it doesn't end in a 0 or 5. If 2 and 3 are both factors, that means 6 is also a factor, and we know that 6 times 7 is 42. And that gives us all of the factors of 42. Last but not least, let's look at the factors or divisors of 70. 1 times 70. And again, 70 is even, so 2 is a factor. 2 times 35 is 70. 3 is not a factor. 4 is also not a factor. However, it ends in a 0, so 5 is a factor. 5 times 14 is 70. And of course, 6 is not a factor, but 7 is a factor. 7 times 10. And we have all of our factors of 70. Well, I need to now look at my common factors between all 3 numbers. So between all 3 numbers, 1 is a common factor, 2 is a common factor, 7 is a common factor amongst all 3 numbers, as well as 14. 14 is a factor of all 3. So of course the greatest common factor would be 14. So I hope this helps you finding greatest common divisor. Now I want you to try a few problems on your own, and I want you to try them by listing the common factors. In our next lesson, I'm going to show you another way of finding the greatest common factor of numbers. So now I want you to try an example. Find the greatest common factor of the numbers by listing the factors. Well, if you took good notes, you should already know the factors of 16 and 28. So let's first list the factors of 16 once again. We have 1, 2, 4, 8, and 16. And then we have our factors of 28. We have 1, 2, 4, 7, 14, and 28. So now we need to look at the common factors. So the common factors we have are 1, 2, and 4. And then we need to look at our greatest common factor, or our GCF, which of course is the largest of those three, which is 4. So at this point, I'm going to have you stop and check your notes. And I will show you what your notes should look like on the next slide. At this point, I want you to pause the video and look at your notes. Double check them with my notes to make sure you have all the necessary information. Now remember, your main ideas, keys, questions, and summary should be left blank at this point. You're just focusing on the note-taking itself. So go ahead and take a minute to pause this video and double check your notes. Now I want you to try finding the greatest common factor of numbers by listing factors on your own. Take a minute to copy down these numbers and pause the tutorial, and then I will go over them at the end. But first, I want you to take a minute and pause. All right, now we'll go over what you should have had. So let's first look at our factors of 60. We have 1 times 60. We have 2 times 30. We have 3 times 20. We have 4 times 15. We have 5 times 12. And we have 6 times 10. And I just want to make sure that I list them in order for you. That also helps me know that I'm not missing any. And then we can list the factors of 96. We have, of course, 1 times 96, 2 times 48, 3 times 32, 4 times 24, 6 times 16, and 8 times 12. So we have 16, 24, 32, 48, and 96. So now we can look at all of the common factors. So we see we have a 1, a 2, a 3, a 4. 5 is not common with both of them. We have a 6. We have a 12. This is why it's nice to list them in order. And then I can see after that I don't have any other common factors. Therefore, my GCF, greatest common factor or greatest common divisor, is 12. So my greatest common factor between 60 and 96 is 12. Make sure you have this copied in your notes and make sure you're showing your work in your notes. Now I'm going to guide you through this example, and then I'm going to have you do another one on your own. And this time I'm going to show you a couple of tricks. So let's first start by looking at all the factors of 14. So our factors of 14, 1 times 14 as well as 2 times 7 is 14. And you can, of course, use all your divisibility rules to check the other numbers in between, but my factors are 1, 2, 7, and 14. 1 plus 4 is 5, so it's not divisible by 3. It doesn't end in a 5 or a 0, so it's not a multiple of 5. So these little tips can help us. So then looking at 70. By now you should use critical thinking skills to see if you see any patterns. Well, 14 and 70, they at least have a 7 in common. So you know that that'll help you when determining greatest common factor. I'm actually going to list out all the factors just to be safe in this case. So I have 1, 2, I have 5, I have 7, 10, 14, 35, and 70. Then I can look at my last number, 91. Whoops, comma. I have 1, and then really you can kind of check your two numbers to see if you have any common factors. You don't necessarily have to list all the factors every time. In this case I am, just to be a good example of listing all the factors, because it tells us to by listing factors. But when you're looking for the greatest common factor, you really do want to look at, okay, well, so far between my two numbers, what's my greatest common factor? Well, I have 14. Is 14 a factor of 91? Well, the fact that 91's not even is kind of a hint that should tell you that no, that's not it. But I do have 7 as my next highest common factor. So my next greatest is 7. So then you need to ask yourself, well, can 7 go into 91? Yes, it can. 7 times 13 is 91. So really all your factors of 91 are 1, 7, 13, and 91. If you can find any others, feel free to bring those in. But looking at your greatest common factor, sometimes it's easier to go down your list. Well, our common factors are 1 and 7. Our greatest common factor, or GCF, is 7. So I want you to use strategies like that when you're figuring this out on your own. You don't always have to list out all of your numbers. Start with your smallest number. You know that no matter what, your greatest common factor is never going to be higher than your smallest number, which I hope makes sense to you. So for example, 14 is as high as I can go. So I'm never going to find a common factor between 14 and any other number higher than 14. Because 14 can't go any higher. So looking at the next problem, which you're going to do on your own, use some of these strategies. And we'll talk about other strategies you can use next time in class, as well as alternate ways of looking at greatest common factor. So now I want you to try to find the greatest common factor of 15, 20, and 75. And use those strategies to help you. In other words, start with listing the factors of 15, and then kind of work backwards from there to see what your greatest common factor could be. And remember, you're comparing 3 numbers. If you feel more comfortable, you can go ahead and just list out all of the numbers and look for patterns at the end. But I really want to encourage you to start looking at patterns at the beginning because they really do save you a lot of time. So go ahead and take a moment to pause now. Now I want you to check your notes with me. So let's start by listing the factors of 15. Always start with the smallest number. That's going to save you time. So my factors of 15, I have 1 times 15. I also have 3 times 5. Now instead of listing all the factors of 20, which you should have in your own notes, on your final copy I'm actually not going to have that while I'm going through it. I'm going to show you how I would do this thinking backwards. I would look at 20 and start backwards. Is 15 a factor of 20? It is not. Is 5 a factor of 20? Yes, it is. 4 times 5 is 20. So far I have a greatest common factor of 5. And then I can see that 3 is not a factor. So it's not going to be a common factor. I know there's others in there, but they really don't matter unless they're common. And of course, 1 is a factor. Then I can look at my next number of 75. Well, 15 is a factor of 75, but it's not a factor of 25, so I really don't even need to look at it. What I need to look at is my greatest common factor between 15 and 25 and ask myself, is it also a factor of 75? And I know that 15 times 5 is 75, so 5 is a common factor. Of course, 1 is, but my greatest common factor is 5. So that's what I mean by working backwards. And this can be a real time saver because I didn't have to list out all of the factors. Here I found my greatest common factor really by using critical thinking strategies. And notice how that saved me time. I didn't have to list out all the factors of every single number. So I want you to start using those strategies. Again, those will really help you with mathematics, and it'll of course help you when looking at similar fractions, as well as later on when you do more advanced math, such as polynomials. So now I want you to take this opportunity to review your notes. Make sure you have all the important information, and you're going to check it in just a minute. But for now, I want you to pause the video and check your notes. Now I want you to take a minute to review your notes. Double check them with mine to make sure you have all the important information. Your last problem might look a tad different than it does in my notes. After you finish checking your notes, make sure you ask at least 3 questions, main ideas, and have some keys, as well as summarize your notes. Another reminder, use the objective or the goal to help guide you with the summary. And that is something that we will look at in class. So just to repeat, our goal was to find the greatest common factor of 2 or more numbers, and we did that today by listing factors. I'm going to show you an alternate method next time. And make sure you double check your notes to make sure that they have all the right information and that you can read them and refer back to them to help guide you and study. Don't forget your questions, main ideas, and summary, and I will see you next time. Good job.